I want you to take a look around your room right now. Like, if you've got an air purifier humming away in the corner somewhere, just look at it for a second.
Yeah, we all have one these days.
Right. And we buy these appliances with a very specific expectation.
Yeah.
We assume they're basically little elimination chambers for indoor pollution.
Exactly. It's a very comforting thought.
Yeah.
You look at that clean, white plastic box, you hear the fan running, and you just naturally assume the machine is solving the air quality problem permanently.
Right. The bad air goes in, the dust, the smoke, the allergens, and they just get neutralized or destroyed. And pure, pristine air comes out.
That's the dream.
But what if I told you that machine might not actually be eliminating the pollution at all?
Oh, this is where it gets good.
Like, what if instead of destroying the bad stuff, it's basically just acting as a temporary storage locker?
Right.
And here is the truly unsettling part. What if, under the right conditions, it is actually spitting that exact same pollution right back into the air you are breathing?
Yeah, that unsettling premise is exactly what we are unpacking today, and it comes from a really fascinating stack of source material for this deep dive.
It really is.
We're looking at a highly technical set of notes, research data, and correspondence from an inventor named Fuchi Wu.
And Wu is definitely not, a casual hobbyist.
Oh, not at all.
He has spent over 20 years obsessively researching ultrafine particles. And based on his extensive engineering notes, he is actively challenging the absolute, undisputed gold standard of the air purification industry.
The HEPA filter.
Yes, the
Yeah.
HEPA filter, which frankly sounds a bit crazy at first. I mean, HEPA is everywhere.
It is.
So our mission today is to dig into his research, unpack the hidden engineering realities of these filters, and discover the critical difference between merely intercepting a pollutant and permanently trapping it.
And we're also going to explore a radically different approach to cleaning the air. I mean, a completely new architecture that Wu has spent years developing to address these specific flaws.
So definitely get comfortable because we are about to look at the air in your home in a completely different way.
For sure.
Let's start with this attack on HEPA, though, because I need some convincing here. As I said, HEPA is used everywhere.
Right. Hospitals, airplanes, clean rooms.
Exactly. I always pictured a HEPA filter as this, I don't know, a microscopic brick wall, like a barrier where particles just hit it and get stuck forever. So how can Wu claim this is a flawed system?
Well, to understand Wu's critique, we have to look at the actual physics of how a HEPA filter operates, because it's not a solid brick wall.
Okay.
It is actually a highly dense web of randomly arranged fiberglass fibers.
Fibers, got it.
Yeah, and when air passes through, the filter relies on a few passive mechanisms. There's interception, where particles just happen to brush against a fiber and stick due to weak molecular forces.
Like static?
Sort of, yeah. Then there's impaction, where heavier particles carry too much momentum to flow around the fiber, so they crash directly into it.
Right, like a car hitting a tree.
Good analogy. And finally, there's diffusion, where the smallest particles just bounce around until they randomly collide with the web.
Okay, so they brush against it, they crash into it, or they bounce into it. But either way, they hit the fiber. Doesn't that mean they are trapped?
See, that's the thing. They are caught, but they are not securely locked away.
Wait, really?
Yeah, the key element Wu highlights here is the physical bond holding that dust to the fiber. It is incredibly weak.
Oh, wow.
The HEPA filter is essentially just a storage device. It holds the particles in place on the surface of the fibers.
Wait, so there's no glue, no chemical bond, it's just sitting there.
Just sitting there. It's held by very weak surface tension and friction.
That is wild.
And in the industrial filtration field, this leads to a phenomenon called particle reentrainment. Some engineers actually refer to it as high-speed redusting.
High-speed redusting, that sounds awful.
It is. Because the particles are only lightly resting on the fibers, any significant change in the internal conditions of that machine can cause those particles to detach and completely re-enter the airflow.
Okay, I'm trying to picture the mechanics of this. So it's not like sticking a piece of Velcro to a wall where it locks in tight.
No.
It's more like a dry Swiffer pad. You run it over the floor, it picks up the dust, but if you accidentally bang that Swiffer against the side of the trash can, all the dust immediately falls right back into the air.
Yes. That captures the vulnerability perfectly.
Mm-hmm.
And the banging the Swiffer equivalent inside an air purifier can be triggered by incredibly mundane things.
Like what?
Well, if the fan speed suddenly increases, it creates a surge in wind velocity
Okay.
or physical vibration from the motor, or even pressure drops as the filter gets clogged over time,
Yeah.
or just the natural degradation of the fiberglass material itself.
Wow, so everyday stuff.
Exactly. All of these alter the aerodynamics inside the machine. The sheer force of the air simply rips the resting dust right off the fiber.
Which brings us to how Wu actually proved this outside of a theoretical lab setting. Because according to his notes, he observed this exact reentrainment happening in his own living room.
Yes, the notes detail what we can call the Xiaomi anomaly.
Right.
This is where the physics of reentrainment become very tangible for a normal consumer.
Yeah, the setup in his notes is pretty straightforward. Wu had a fresh air system running in his house, and the room was completely clean.
Spotless.
And he had a Xiaomi air purifier sitting there with a built-in PM 2.5 sensor, which, just a reminder, PM 2.5 measures those dangerous fine particles that get deep into your lungs.
Right, the stuff you really want to avoid.
Exactly. So the sensor is reading a perfectly clean score of 10. Then, just to see what happens, he manually turns the purifier's fan speed all the way up to high.
Just cranks it up.
Yeah. And the immediate result is what completely validates his theory.
It's crazy. Without any windows opening, without any outdoor pollution coming in, that PM 2.5 sensor instantly shoots up from 10 to 30.
Boom. Just like that.
Yeah.
And it didn't just spike and settle. The notes emphasize that it took a full hour for that sensor reading to slowly drop back down to 10.
An entire hour.
So if the room was clean, where did that massive cloud of pollution come from?
It came from inside the purifier itself.
That is just so gross to think about.
It is. Wu's analysis breaks down the fluid dynamics happening inside the plastic casing.
Okay.
When he cranked up the fan, it created intense wind shear.
And wind shear is just a difference in wind speed and direction, right?
Right.
Over a short distance.
Exactly. So inside that tight duct, the high-speed air essentially scraped along the boundary layers of the fan blades, the inner plastic walls, and the surface of the HEPA filter itself.
And all the surfaces were just coated in the dust it had previously caught.
You got it. The high-velocity air overpowered the weak surface tension holding those particles. It sheared the ultrafine particles right off the components and blasted them out the top of the machine.
They just circulated in the living room for an hour, slowly settling on furniture or eventually getting refiltered. That is incredibly counterintuitive. I mean, think about how a typical person uses one of these machines. You're cooking in the kitchen, you accidentally burn something, and the room gets smoky.
Right, or allergy season hits and you start sneezing.
Yes. Your first instinct is to walk over to your purifier and blast it on high to clean the room faster.
Of course it is.
But based on Wu's observation, turning it to high might just be ripping weeks of stored pollutants off the filter and blowing them directly into your face.
It really forces you to question the entire architecture of passive filtration. I mean, if your primary defense against pollution is a temporary storage net that actively leaks when the wind changes, you need a different strategy.
And that realization is the core of Wu's entire thesis. He argues that the industry needs a paradigm shift away from passive storage and toward active, permanent entrapment.
Right.
He actually designed an alternative system to prove this could be done, which he named Little Heaven.
Little Heaven, yeah.
And here's where it gets really interesting. The most striking detail in his schematics for Little Heaven, there is no HEPA filter anywhere in the machine.
Which is wild. That would be considered commercial sabotage in today's market.
Right.
I mean, if it doesn't say HEPA on the box, consumers won't touch it.
So how does Little Heaven actually catch anything without that dense microscopic brick wall?
By fundamentally altering the particles before they ever hit a filter.
What do you mean?
Well, a traditional HEPA system is a brute force method. It uses an incredibly dense weave to physically block the air, which creates massive wind resistance.
Right, which means the motor has to work incredibly hard, using tons of electricity and making that loud droning noise just to push air through the blockage.
Exactly. But Wu bypasses that entirely with a multi-stage relay approach.
Okay.
In the Little Heaven architecture, the air first enters a first ionization zone.
Ionization.
Yeah, here, high-voltage electrodes release ions into the airflow, which attach to the incoming pollutants. This gives every particle an electrical charge, either positive or negative.
Okay, so we are electrifying the dust. Why does that matter?
Because it changes how the dust behaves when it reaches the next stage. After the ionization zone, the air passes through electrostatic cotton and then an E12 electrode-pleated filter.
Electret.
Yeah. Electret means the fibers in the filter have been manufactured to carry a permanent static electrical charge, much like a permanent magnet.
Ah, I see where this is going.
Yeah.
Wait, so HEPA is basically a giant, dumb bouncer just standing in a doorway blocking people. But WU's system is like a high-tech security checkpoint.
That's a great way to put it.
It actively tags or charges the particles first, so they naturally stick to the walls like magnets. Like if you take a balloon, rub it on your hair to give it a static charge, you can stick it to the wall and it stays there perfectly. It actively grips the surface.
Exactly.
But if you just take a normal, uncharged balloon and throw it at the wall, it just bounces off or slides down to the floor.
That is the exact mechanism. Because the particles are charged and the filter is charged, they attract each other electromagnetically.
Wow.
The dust doesn't need to physically crash into the fiber to get stuck. It is actively pulled out of the airstream and locked onto the material.
And because it's using magnetic attraction rather than physical blockage, the electric filter doesn't need to be woven nearly as tightly as a HEPA filter.
Precisely. The gaps between the fibers can be much larger. That translates to incredibly low wind resistance.
So more air gets through.
Yeah, the air flows through easily, which means the fan doesn't have to work as hard, power consumption drops dramatically, and the machine operates much more quietly.
Okay, but hold on. Even with electrostatic attraction, air is messy.
Sure.
There are pollutants floating around that are incredibly tiny. I'm looking at the notes on PM 0.1. Those are particles that are a fraction of a micron.
Oh yeah, the really small stuff.
They're so small they can travel deep into your alveoli and cross directly into your bloodstream.
Okay.
How does a looser net catch something that microscopically tiny even if it has a charge?
Well, that is the most challenging engineering problem in air purification. And it brings us to the final stage of WU's system. After the electric filter, the air flows into a second ionization zone and then enters a component WU refers to as the death black box.
The death black box.
I know, right?
It sounds like a villain's weapon in a comic book. What is actually happening inside this box?
It is a highly engineered labyrinth.
A labyrinth.
Yeah. Traditional filters struggle with PM 0.1 because these ultrafine particles don't follow straight aerodynamic lines. They exhibit something called Brownian motion.
Brownian motion.
Yes. Because they have so little mass, they're constantly bombarded by the actual gas molecules in the air.
Oh, I see.
This causes them to vibrate and move in erratic, chaotic, zigzagging patterns. Imagine a tiny rowboat being tossed around randomly in a violent storm.
Okay, so you can't just catch them with a net because they're constantly dodging and darting around in the airstream.
Exactly. So WU's death black box doesn't try to catch them with a net.
What does it do?
It forces the airflow through a complex path with sharp, sudden 90-degree turns.
Oh.
Air, being a gas, can easily navigate those sharp turns. But the PM 0.1 particles, exhibiting that chaotic Brownian motion, cannot.
They can't turn fast enough.
Right. As the air whips around the corners of the labyrinth, the particles are subjected to close-range impaction.
So they essentially drift wide on the turn and crash into the walls of the maze.
Exactly. And here's where the active capture is finalized. The walls of this labyrinth are not just plastic. They are oppositely charged electrode plates.
Whoa!
Yeah, so between the mechanical inertia throwing the particles against the wall and the intense positive and negative electrostatic attraction locking them in place, the PM 0.1 particles are permanently fused to the walls of the box.
So they aren't just resting on a fiberglass thread waiting to be blown back into the room.
No.
They are magnetically plastered to a metal plate.
Yes. And if we connect this to the bigger picture, WU's philosophy here is critical. Caught does not equal destroyed. A pollutant resting in a dense net does not mean you are safe. In his engineering framework, true safety means the pollutant is permanently entrapped and physically incapable of returning to the breathing environment, regardless of wind speed.
The physics of this makes so much sense. I mean, you have active magnetic capture, permanent entrapment of ultrafine particles, lower noise, and less electricity.
It's a massive upgrade.
So if this active architecture solves the fatal flaws of passive storage, why is the entire industry still obsessed with HEPA? Why does every single purifier at the hardware store brag about its HEPA rating and nothing else?
Because the industry is not built on selling long-term air quality. It is built on selling standardized metrics. The market has been trained to look for very specific numbers on the box.
You mean things like CAR, the cleaner delivery rate?
Yes, CADR, and the famous 99.97% interception rate.
Right, and WU's notes contain a pretty scathing breakdown of these marketing illusions, particularly regarding that 99.97% claim for PM 0.1 particles.
Oh, it's fascinating. He highlights a major historical discrepancy. Well, in the late 2010s, Specifically, after major smog events in Asia brought air quality into the mainstream global consciousness, there was a massive boom in air purifier marketing.
I remember that.
Suddenly, every consumer brand was claiming their machines captured 99.97% of PM0.1 particles.
But Wu points out a major red flag with that timeline.
Yes,
He notes that the precision equipment required to actually measure something as small as PM 0.1 was completely out of reach for these consumer companies.
completely out of reach. It requires highly sophisticated, incredibly expensive machinery. Standard laser sensors, like the ones built into most home purifiers, cannot see PM0.1.
Because they're just too small.
Yeah, the wavelength of the laser is too large, the tiny particles just scatter the light invisibly.
Mm-hmm.
To measure them, you need a machine called an SMPS, a scanning mobility particle sizer, or a CPC, a condensation particle counter.
Wait, so if lasers can't see the particles, how does a CPC machine actually work then?
Well, it uses thermodynamics.
Okay.
Basically, it passes the air through this heated, saturated chemical vapor,
Yeah.
usually alcohol.
Alcohol.
Really? Yeah. And then it rapidly cools it down.
Oh, so it condenses.
Exactly. The vapor condenses right onto those invisible PM0.1 particles, physically growing them into larger droplets until they're big enough for a laser to actually detect.
That sounds incredibly complex.
It is.
And Wu's point is that consumer appliance factories in 2015 did not have these million-dollar thermodynamics labs sitting on the assembly line.
Not at all. They were almost exclusively found in high-level university research labs and specialized semiconductor facilities.
So if the manufacturers couldn't actually measure PM 0.1 on the assembly line, where did the 99.97% figure come from?
According to Wu's analysis, it was largely an extrapolation.
An extrapolation. So basically they were guessing.
Pretty much.
Mm-hmm.
They tested how the filter performed against larger, easily measurable particles, and then just drew a theoretical math curve to guess how it would handle the tiny stuff. They were selling a mathematical guess as a hard engineering fact. Furthermore, even when a machine is properly tested in a lab and earns that 99.97% rating, we have to look at how the lab test is conducted versus how you actually live in your home.
Yes, this is the part that really frustrated me when reading the source material. A lab test is basically a fantasy environment.
Completely.
They take a brand new, fresh out of the plastic filter, they run a very specific size of test dust through it at a constant, unchanging airflow in a room with perfectly controlled humidity and temperature.
And that pristine environment guarantees maximum surface tension and zero re-entrainment. But your bedroom is not a sterile lab.
Exactly. In reality, the rubber seals on your machine age and warp over time, allowing air to bypass the filter entirely.
Yeah.
The humidity in your house spikes when it rains, which changes the static charge of the air. You're using a filter that has been gathering dog hair and dust for 6 months.
And, as we saw with the Xiaomi anomaly,
Yeah.
you are constantly changing the fan speed, ripping the boundary layer of air and causing wind shear.
So what does this all mean? The lab gives the machine a flawless score on day 1, but it does not account for the degraded performance, the leakage, and the massive re-entrainment that occurs on day 180 when the fan is suddenly put on blast.
So millions of people are buying a standardized test score.
Right.
They're purchasing a comforting number printed on a box, assuming it represents a permanent shield, when in reality, that score completely evaporates after a few weeks of real-world use.
Wu's thesis suggests that consumers have been trained by marketing departments to demand a specific component, like, does it have HEPA, rather than demanding a specific result.
Exactly. We should be asking, where does the ultrafine dust actually go, and what guarantees it won't come back out?
It's like butting a high-security vault based on how thick the steel door is without realizing the back wall is made of cardboard.
That's perfectly stated.
It looks great on the spec sheet, but it fails in practice. Wu's team believes that as more people experience active entrapment architectures like Little Heaven, the market expectations will eventually shift.
For sure. I mean, once you experience lower power bills, zero mechanical noise, and air that stays clean regardless of fan speed, the obsession with HEPA will start to fade.
It's the natural evolution of engineering.
Eventually, physical reality catches up with marketing.
Well, let's bring all these threads together because Wu's notes offer a complete re-education on how we view indoor air.
They really do.
We started by exploring the physical limitations of traditional HEPA filters, how relying on weak surface tension makes them temporary storage units, highly vulnerable to reentrainment, where changes in wind shear blast pollutants back into the room.
And we examine the mechanics of that vulnerability through the Xiaomi anomaly, proving that stored dust on fan blades and filter surfaces is easily knocked loose.
Then we looked at Wu's Little Heaven architecture, which abandons HEPA entirely.
Bold move.
Very bold. By using active ionization to magnetize particles and an electrode filter to catch them, he dramatically lowers wind resistance. And for the untrappable PM 0.1 particles, the Death Black Box uses the physics of Brownian motion to slam them into charged electrode walls, achieving permanent entrapment.
And finally, we closed by looking at why this active technology is fighting an uphill battle against industry marketing.
Right, that 99.97% standard.
Yeah, it's heavily reliant on theoretical extrapolations and pristine lab conditions that completely ignore the humidity, aging, and airflow variations of a real home.
If Wu's research proves anything, it's that we put entirely too much faith in a controlled lab score.
We really do.
So what should we trust? According to Wu's philosophy, the ultimate metric isn't a percentage on a shiny box, it's your body feel.
Body feel, I like that.
Yeah, it is how well you sleep, how clear your sinuses are when you wake up, and whether your home legitimately feels fresh month after month. Marketing can spin a mathematical curve, but physical engineering in the real world does not lie.
It is a strong argument for trusting physiological results over industry certifications.
It really makes you rethink the appliances you rely on. And I want to leave you with a lingering thought today.
Okay.
We just spent this time exploring how an entire multi-billion-dollar air purification industry could build its foundation on a lab metric that arguably doesn't hold up to the messy reality of long-term use.
Right.
It makes you wonder what other gold standard numbers on the appliances in your home are just marketing illusions hiding in plain sight.
Oh, that's a good question.
Think about that the next time you look at a glowing energy efficiency rating or a pristine performance label on your washing machine or your refrigerator. Keep questioning the standards and keep learning. Until next time.